So till now we have discussed about metals and their characteristics. Coming next is non-metals. Non-metals. The word itself says non, which means opposite to what we discussed until now of metals, okay, which is not at all a metal. The quite opposite word is non-metals, okay. What are the properties so far we discussed up to now in the metal category is quite opposite for all the non-metals, okay children. So in the non-metals we'll see what are there. So non-metals are quite opposite to the metals and the properties are also completely different from that of metals. Properties are quite opposite to metals. That's it children. Okay, as simple as that. To metals. Okay. So out of 118 elements in the periodic table, there are 24 non-metals including noble gases. Okay, I have included this number and I have given you 24 is the number including noble gases. Okay, so all these non-metals are divided into 3. 12 as solids, 11 as gases, and only one non-metal is liquid in nature. You know what is the one element which is liquid in non-metal? Oh, you know children? It is bromine. Bromine. The symbol is capital B and small r. Okay. So we'll discuss what are the characteristics of non-metals now. Okay. Characteristics of non-metals. Characteristics of non-metals are quite opposite to that of metals. Okay. The very first non-metallic category or else the characteristic is these are lusterless. Okay, we discussed metals are luster in property, okay, the shiny, the metallic glow, all we discussed now children. So here non-metals are lusterless. You can also write as non-luster, which means they don't have any shining appearance on them. They are very dull in appearance. They're very dull in appearance. Okay, so not at all shiny, they're lusterless and they are dull in appearance. Okay, what is the second point we discussed children? Metals are good conductors of heat and electricity, right? But here, the non-metals are bad conductors. Non-metals are bad conductors of heat and electricity. Heat and electricity. Okay? And the third very point is ductility and malleability of metals. Okay, as metals are ductile and malleable, here the non-metals are non-ductile and they are not malleable too. These are not ductile and non-malleable. Okay, there are not ductile and not malleable. Okay, yes, not ductile and they are not malleable in nature. Next, coming is all metals are solids at room temperature. Okay, but here non-metals are brittle if solid. You know what is the meaning of brittle? You know what is the meaning of brittle? Brittle means they can easily broken down. Okay, if they easily break, that property is called as brittle. That term is named as brittle. Okay, suppose if you take a piece of chalk, if you just press it, it will break in 2 pieces, right? That's the property of brittle. So non-metals are brittle if solid and most of them are gases. They exhibit in gaseous form. Okay, and non-metals have low melting points and low boiling points. Non-metals have low melting points and low boiling points. And the last property, non-metals are not producing any sound. These are not at all sonorous substances. They not produce any sound. Okay, they not produce sound because these are non-sonorous materials. Okay, So they are dull in appearance, bad conductors, non-ductile, not malleable, brittle if solid, and mostly are gases, and low melting points and low boiling points. They not produced any sound. So here let me give you examples of these children. Lusterless, non-luster, it is dull in appearance. Na? All these things you have might observed outside, but there are some exceptions included here, okay? As exceptions included in metals, there are also exceptions included in non-metals. Let me tell you what are the exceptions of this particular luster property, okay? All the non-metals are lusterless, but there is two particular non-metals which are very shiny in appearance. Those two are graphite and iodine. Graphite and iodine are shiny in appearance. Means what? They are lusters. Okay, which means these are the exceptions of non-metals. According to the lustreless property, we said all the non-metals are lusterless, which means they have dull in appearance. And you know, one more point I want to include here. These non-metals, they cannot be polished further. Okay. Coming to gold and all these things, silver, the metal category, they can be polished to get extra shiny look. But here, non-metals, they cannot be polished. Okay. That condition is called as lusterless property. But there is an exception. The two exceptions are graphite and iodine. Graphite and iodine, they do have luster property, which means they are shiny in appearance. And here, bad conductors of heat and electricity. Exception over here is graphite. Graphite is a good conductor of heat and electricity. Okay, these are the examples. And one more, children. I said no, all these non-metals may be some solids and gases, and there is also a liquid particular non-metal. That liquid non-metal is bromine. Bromine is a liquid non-metal. Bromine is a liquid non-metal. Do you remember what is the liquid metal? Mercury, right? Hg. And also gallium in some cases of, 30 degrees centigrade. Here, bromine is a liquid non-metal. And bromine's atomic number is 35. Okay. This 35 containing number bromine is a liquid non-metal. Okay. These are properties, characteristics and exceptions included in red pen, red color. These are the characteristic exceptions of non-metals. Okay. Coming with pictures. Yes. Physical properties of non-metals. As we discussed, these are the bad conductors of electricity. Okay. There are dull in appearance. There is no particular shiny nature. And there are brittleness, easily breaking into pieces or easily broken into some other, because they are brittle in nature. Okay. And they are very soft. Okay. Coming to metals, metals are very hard, right? So here non-metals are soft. And yeah, list of common non-metals. Okay, hydrogen. Hydrogen symbol is H, capital H. Hydrogen is a gaseous state and it is a colorless gas. Okay. Next, coming with nitrogen. Nitrogen symbol N in gaseous form. Nitrogen symbol N, capital N element, and it is state is gaseous state and it is colorless. Okay. Coming to oxygen. O symbol is O, oxygen symbol, and the state is gaseous state and it is also colorless. Coming to fluorine, capital F. It is also exhibiting in gaseous state and colorless. Coming to chlorine, Cl. Okay, Cl. Here it is in gaseous state and it is yellow in color. It is yellow in color. The chlorine gas is yellow in color. You know, the chlorine exhibits in Cl2. The gaseous form of chlorine is Cl2. Okay, it exhibits in Cl2 and it is yellow in color. Okay, bromine. Bromine is liquid at room temperature and it is having brown color. The symbol of bromine is Br, capital B and small r. Okay. Iodine. Iodine is solid in nature and it is also brown in color. Iodine symbol is capital I. Okay, children. Carbon. Carbon is also solid and it is gray in color. Carbon symbol is C. And coming next is phosphorus. Phosphorus, capital P. Symbol capital P. And it is having a state solid and the color is waxy yellow in color. Next comes sulfur. Symbol of sulfur is S, solid in state, and it is also having yellow in color. Silicon, capital S and small I, because capital S we also already used for sulfur, right? So we are including one more letter Si, which means silicon, that is having state solid, and the color is gray. So these are only the symbols, okay children, these are all the symbols of the particular element I have given you. Okay, these may exhibit in different forms. I'll discuss what is that later. These are just the symbols of the particular elements. Okay, and they're exhibiting in gaseous state or solid state, or one exception, that is liquid state, that is bromine, which is brown in color. Okay children, so this is all about non-metals. And yeah, so far I told you, no, bromine is a liquid non-metal. See the liquid nature, and it is brown in color. The brown colored bromine, the atomic number 35. Okay, this is bromine. And yeah, here. So after knowing what are metals and what are non-metals, the third category in the particular classification is metalloids. What are metalloids? What are metalloids? You know children, metalloids are something which have both the properties of metals as well as non-metals. Okay, metalloids are something, but they have some properties of metals and some properties of non-metals. Some properties of metals and some properties of non-metals combined together to give a substance called as metalloid. That's it. Simple. Okay. What is a metalloid? The metalloid is something which contains some properties of metals and some properties of non-metals. When they group together, that is called as a metalloid. Okay. Examples of metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. How many are there in number? There are 7 in number. Okay. Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. You want me to write the names over here, children? Yeah, I'll do it for you. See, boron, B-O-R-O-N, boron. Okay. And Si means silicon. Ge stands for germanium. Okay. And As stands for arsenic. Sb means antimony. Okay. Te means tellurium. And Po means polonium. Okay children, all these 7 out of 118 elements are metalloids. How many are there? 7 out of 118 elements. 7 are metalloids. Okay, this is all about metalloids. And coming next is the last one. The last classification in the element section is, what's that? Noble gases. Noble gases. What are noble gases? There are some separate column. Did you observe periodic table in the last lecture, children? The previous session I told you that periodic table contains from 1 to 118 elements. In that, the last column, if you see the last group, is nothing but noble gases. Present towards the right corner in the periodic table. Okay, it is named as 18th group or 8A. Okay, so that group is called as noble gases or rare gases. Let's discuss what is that now. Okay, noble gases are something which are found in air, in the form of gas. So the gases which are found in air in the form of, the gas found in air is called as, just a second. Okay, so the gases, the noble gas is something but these are found in air in the form of gases. And these gases, they will not react with any other elements. They don't have any interest to react to any other elements. Okay, that property, that condition is called as inertness. Okay, what is that, children? They don't have any reaction with any other substance. They can't react, don't want to react with any other substance, and that property is called as inertness. Hence these are called as inert gases. Hence these are called as inert gases, or we can say as noble gases. Okay, because they don't want to react to any other elements. So these are inertness, they have the property of inertness. These are named as inert gases or noble gases. Okay, and there is also other name, children, for this, that is aerogens. Okay, aerogens, inert gases, noble gases, all these are names of the particular noble gases. And there is also other name called as rare gases. Rare gases. You know why these are named as rare gases? Because in the atmosphere they are present in very little amounts, children. Okay, they are present in very little amounts. Okay, the traces we can say. So in that condition we can say the other name of noble gases are rare gases. Okay, where these are present? In the long form periodic table, right, complete right corner, which include the group number 18 or the Roman number 8A. Okay, so these are the noble gases, and namely noble gases are, starting from there we can write like this, children. Here, helium, neon, argon, krypton, xenon, radon, and oganesson. All these 7, okay, all these 7 are noble gases. How many number? 7 out of 118 elements are noble gases. And this noble gases, this number are also included in non-metals. Okay, out of 118 elements, 7 gases are noble gases. Okay, children, namely helium, neon, argon, krypton, xenon, radon, and oganesson. Okay, so there is a 2 point here to be noted, children. Here, helium, the element is there, no? Helium is the second element in the periodic table, and helium is considered as the second most lightest element. Second lightest element after hydrogen. In the whole periodic table, helium, He, is the second lightest element after the element hydrogen. Okay, and one more point to be noted over here is radon, Rn. Radon is appear from radioactive emission from the earth. Okay, let's see what are those. Okay, yeah, here you can see some of the noble gases over here. Helium with symbol He, neon, Ne, argon, Ar, krypton, Kr, xenon, Xe, radon, Rn. Here the next writing oganesson. Let me write that, children. Oganesson. Symbol capital O and small g. All these 7 gases are noble gases. Other names are inert gases, rare gases, and also aerogens. Okay, so all these helium, neon, argon, krypton, xenon, radon, and oganesson are present in the right corner of the periodic table, included in group 18 or Roman number 8A. This is all about the classification of types of elements. Okay, what are types of elements, children? Types of elements are 4. We are into 4. Metals, non-metals, metalloids, and noble gases. So here ends the particular session, and you can also see this percentage of element by weight in the atmosphere. Okay, so in the Earth's crust, how these elements are weighted by percentage. Oxygen is the most abundant in the Earth's crust, which included with 49.85%. 49.85%. Coming to next is silicon. Silicon is present with 26.03 percentage. Okay, the abundance of elements in the earth's crust. We're discussing about that. Okay, next comes aluminium 7.28, iron 4.12, calcium 3.18, sodium 2.33, potassium same 2.33, magnesium 2.11, hydrogen 0.97, titanium 0.41, and other elements so 1.39. Okay, this is not about the atomic weight, children. This is all about the abundance of the elements in the earth's crust. Okay, what is the most abundant in the earth's crust? Yes, oxygen. Oxygen is the most abundant in the earth's crust. So far we have discussed about types of elements and the abundance of elements in the earth's crust. Hope you enjoyed this session. Thank you.